Back to the next module. By now, you have been able to, you've learned how to make columns, beams, slabs, and also you have also learned how to make walls and also loaded our beams and done a building model check. And also, yes, so the next thing we are going to be learning how to do is going to be the analysis, the structural analysis. You have your building model, which is correct with no errors. So next we are going to learn how to do is to analyze your building. So before you analyze your building, you have to decompose your loads. You come to your loading after your modeling, you come to your loading, come to your load decomposition by finite elements. That's what it means by FE, right? You click on it. Notice you're on story 2. It's a story that if you move this, you realize that it's story 2 that you were on, so it just automatically highlights story 2. What you can do in this case is you can decide to calculate slab loads, which is going to calculate slab loads for that particular story. Okay, it's running the load decomposition just to distribute the loads from your beams, from your slabs to your beams, and from your beams to your columns, and your column sends it down. So that's all what it's doing. So it has finished doing that. If you notice, writing story 2 analytical model prepared, so it's still loading and it has brought out the analytical model. You can zoom into this and just rotate it. So if you notice, it has broken down the slab panels into smaller bits. It has done the final element of it. So you can just click OK, and so it's performing finite element slab analysis for beam decomposition. So the analysis for that story 2 is complete. It has been checked here. Or also you could just come here to select all of it. Okay, once select all of it, it will start from your story 3. It will run from your story 3. Okay, so sorry, you close this first of all. You close that, sorry, then you come to your fixed end, you click that again, you select everything, right? Then you come to your calculate slab loads. What this does is that it starts from the last story, that's the story 2, and decomposes the load from story 3 to story 2 and to story 1. That's what it does. So it has finished for story 3. See, story 3 fixed end load decomposition model. It has done it for story 3. Press OK. It's going to move from story 3 to the next story. So it's done with story 3. It has moved to story 2. Same thing. It has decomposed the model for story 2. You press OK. And it's going to do the last one for the story 1. For story 1, so you press OK for story 1. So it's analysis complete. You notice everything is checked. So it has decomposed and it has analyzed every. It has not really done the building analysis, but then it has decomposed your load for your loading. It has transferred your loading from your slabs to your beams, from your beams to your. That's what it just means. So you can close this, and that's that. So the next thing you do is for you to come to your analysis. It's for you to come to your analysis. Come to your building analysis. So this is more like your command center where you check and make sure everything is complete. Your material strengths you wanted, your steel grades you wanted. So for your pre-analysis, you have your project parameters and loading. So this is loading, this is setting center. We started this tutorial, we started with as setting center, where we had to go and pick our parameters, the codes we used, the units, and everything. So if we didn't do that, you can use this opportunity to come to your project preferences, the title. If you didn't do that, you can also now, you remember we did it, Ruby structure and this. So if you did not do it, you can use the opportunity and get that fixed. The next thing is your loading combinations. Remember we did this when we wanted to input our slab. We did the loading combinations. We want to fix this, so you can that's okay. So this, because of the area we are designing for, we are not really disturbed in this part of the world. We are not really disturbed with wheel loading, and it's just 3 stories. So when it's 3 stories, you don't really need the width load and story load. But then if you click on it, you see, you don't really need. So you can just, if you could calculate it, but it's not really, it's going to, the effect is going to be very, very negligible because it's just a 3-story building and we are not really affected by wind in this part of the world, so you can, okay. Then you come to the materials, you edit your materials. Edit materials. So for your concrete columns, it's by default it's saying your concrete strength is going to be 35 by 45, but then it's good to be safe. So you're going to be designing with respect to a 20 by 25 concrete strength. So you click. So we can just apply this to all members of the story. Apply this, and you click OK. Then you notice that the concrete strength for every concrete member has been changed to 20 to 25. Also the grade, you can click on this steel grade, and we're going to design to grade 410 type 2. You click, you can apply to all members, and you click OK. We are only dealing with concrete members. We are not doing any steel connection in this tutorial, so we are going to leave this for now. Come to your foundation floor, do the same thing. Foundation, you can click on it, apply to all members, and you click OK. Alright, so you come back to your default materials. You're going to be checking the kind of, yeah, you come back to your, yes, you come back to this, and that's that. And you can click OK for your pre-analysis. You can come to your model options, checking other things like the material and section effective ratio, your default settings. Yeah, your beam section analysis. Do you want to analyze your beam as a flange beam or the rectangular beam? So we are going to use a rectangular beam. So your source structure, what do you want to use? Do you want to use a main foundation model, or you want to use a user defined? We're going to use a user defined because you know your foundation, your source acts like a spring. So we are going to use the user defined support, and keep design. You go next to your analysis. We did our building model check, but then you can still check it again if you want to. You can do your building model check. Everything is checked, and we start. And it runs the model check for us. Number of errors is 0, so you can just close this. Then you come to your building analysis. Click on your building analysis. You have this drop down with these bar design options. So you want to analyze for columns and wall reinforcement design and beam reinforcement designs. So after analyzing, you want it to design your columns and you want it to design your beams, right? This other option says we select bars stroke design. So in case you designed and maybe the software provided 2x16 top, 2x16 bottom for your beam, if it doesn't pass, like for example it doesn't pass, what do you want the software to do? Do you want the software to redesign the bars, or you don't want to redesign the bars? If you want to select the bars, then you can click this, but for now we don't want to select the bars. We want to see what the reinforcement provided based on the analysis we are getting from our loading. So we can just start building analysis. I like to give it time to analyze. It doesn't take a long time. So since we did not check for the reselect bars, you notice that it's just checking steel, that it don't select steel when previous bars are insufficient, so it doesn't reselect these steel bars. But then if we had checked when we were doing the analysis, the two bars, it would have reselected the bars for us. For those that didn't pass, it would have reselected it. But for now, this is where we are. We don't want it to reselect. We want to see what it has provided. So in case there are other positions we want to change, we could change it. Yeah. Okay, so it's done. We have relative story drift. It's okay. The direction 2 drift limit is okay, so click OK. So it has finished. Analysis completed. Right? It's very, very important we check our axial load comparison reports. This will help us to know what we are dealing with. If you click on your axial load report, or click on the report, and you give it a little time to load. So it's to produce the reports, and you have the axial load comparison reports. Okay, so on the first one, you have the total load based on slab loads. We've seen the dead load from the story 2, story 3, story 2, and story 1, and you have the total. Alright, and this is the live load, story 3, story 2, story 1, and you have the total. Okay, so now the next one, the total loads decomposed to beams. That's the slab loads. This one wasn't decomposed to beams. This one is just the slab loads alone. This other one is now from the slab loads, the ones that are now decomposed to the beams. So you have a total of this, and you have a total of this. If you notice what happens on the total of the dead load, you have about 8,224.5, and also at the dead load you have about 8,234.9. You notice the just small discrepancies, very little. The code allows for just 5% of that discrepancies, right? So in case you did your analysis and you realize that your total load, dead load, is about 5,000, for instance, and your live load, the one decomposed beams to beams is about 10. That's almost like 100%. That's more than 5% that the code allows. It means that there's something wrong with your building model, something wrong with the loads and the forces acting on the building. It's not making the building stable. You have to go back and make sure you check your model again and redesign and reload your structures, and if possible look for a way to avoid sway and all of that stuff. So that's how you know that your building analysis is correct. So at most 5% discrepancies from all of this, that's what it means. So you check your building analysis column and what Excel, which is 8,234.91. So it's just